everybody. My name is NhatNguyen. I'm doing a MME 504 classes, finite element analysis. So for the project, I'm thinking of doing a finite element analysis for the hydraulic engine mount, including fluid-solid interaction. Um, for today, I'm gonna go through the introduction. We're gonna see some application of the FEA in the project and my personal idea about some steps how to assess the project. Introduction. So, what is the hydraulic engine mount? As a mechanical engineering student, so probably we're gonna study about the internal combustion engine class, and y'all probably gonna have like some mindset about the engine. So the hydraulic engine mount is usually like attached to engine, and it's gonna help you to isolate the vibration that transmit from the engine to the chassis. That the chassis is gonna connect to the frame of the vehicle, and the hydraulic engine mount is gonna have the rubber fluid-filled chambers and inertia track RFI's plate. So the rubber, we're gonna have two type of rubbers. So the primary rubber, we call it a rubber top spring, which is the rubber on the top. You can see it right away on the pictures on your right. And the other rubber, we call it a secondary rubber, and that's a rubber bellow. It's on the bottom. For the RFI's plate, we're gonna call it flow channels also, and we're gonna have two plates like that gonna be connected by the inertia track, and in the middle of that we're gonna have the decoupler. So the hydraulic engine now they're gonna use the ethylene glycol fluid, which is the same fluid that we use in the hydraulic brake. Coming through the operational principle of the hydraulic engine mount. So the basic thing of the hydraulic engine mount, they're gonna help the vehicle to reduce engine vibration, minimize the noise transmission, and then it's gonna bring the comfort to the passengers. And in the condition situation, the hydraulic engine mount is gonna react differently to two kind of conditions. So firstly, that is the low frequency and large amplitude one, and secondly, that is a high frequency and small amplitude. For the first one, when we're talking about low frequency, large amplitude excitations, e.g. idling and load changes. So when you're in an idling state, you turn on your car on but not moving it. The key component in this condition is the inertia track. The upper chambers is gonna compress this, and then it's gonna push the fluid into the inertial track. And because of the narrow and long shape of the inertial track, it's gonna have the resonance effect, and then it's gonna lead into the good dampen engine vibration. It's gonna help you to dampen the engine vibrations, kind of. In this hydraulic engine mount, for the low frequency and large amplitude condition, the most important thing is the damping mechanism. So the hydraulic fluid that move in between chambers is going to help you reduce its impact from the low frequency vibration. And the damping is adjusted to match with the engine natural frequency. Other than that, the fluid flow through the orifice is gonna dissipate energy as a resistance and convert the vibration energy into the heat. I'm sorry, I miss writing it. Like I did it at late night, so actually the class is 504, not 540. I'm sorry for that. And the second condition is the high frequency small amplitude excitations, which is high RPM one. And the key component in this condition is the flow channel and the orifice. So when the engine runs at a high speed, it's going to generate small but rapid vibrations. And the small orifice is going to help the creating frictional resistance also. And also rubber top spring going to help you to absorb some minor vibrations. And the elastomeric component gonna play the important role in this. It's gonna absorb most of the high frequency vibrations. In conclusion, we can say hydraulic engine mount is gonna help you to adjust some stiffness and ambient effect behavior based on vibration conditions, exactly as wave vibration. The inertial track gonna plays an important role in controlling the low frequency damping, and flow channel orifice is more useful at high frequency. For the applications in FEA project, first thing first, I want to talk about modeling and simulation. So hydraulic engine mount is a small component, but we have a lot of pieces inside of the hydraulic engine mount. And the other one called decoupler, which is a very complicated one to module and simulate. So at this time, I will not consider it in my project, but I will think about it in the future. So the parts that I would not module, I would create a 2D CAD or 3D CAD in space clamp ANSYS, which are rubbers, chambers, inertia track, and the flow channel, which is called orifice. I would say going to this project, we're gonna have some challenges for students to get into it because it is a fluid solid interaction project. So you have to study both FEM, finite element method, and have some knowledge about computational fluid dynamics also. For this one, we have to understand the mechanical modules to describe the system property, which is called lump mechanical module. That's the reason why I have to take a look about that also. And then we should have the strong foundation in pre-processing and post-processing. For the pre-processing, the data collection is very important. And these are some of the challenge for me also at this time because due to limited information about the hydraulic engine mount on the internet. For the FEA methodology, I would say I will step by step assess to it like any other structural analysis project that we used to do. We used to do. So first thing first, I will read and gather papers and in order to collect data, and I want to see how the experiment and how they're gonna do the experiment, and they compare the result from the experiment with the lump mechanical model, or also with the paper about the fluid solid interaction. After that, I would prepare and create a 3D model of the HEM in ANSYS. And then I'll prepare data parameters to set up for the pre-processing process. And then start meshing, checking the convergence features of the mesh structures and task if possible. Then I would run the task, checking the result, compare with the experiment, and with the lump mechanical method. And then we start to write the final project. Any questions, please comment below and I'll try my best to answer your question. I truly appreciate that. And thank you for your listening.